Hi students, coming to the next algorithm, that is the round robin algorithm. Now let us see what is this round robin scheduling algorithm. So in round robin process, the processes are dispatched. Here the processes, whatever the processes that are the CPU is executing, that processes are dispatched. First they are dispatched in FIFO, first in first out. So they follow the CPU follows the method as first in first out in a manner, FIFO manner, but that process are given limited time. So for each process here we are giving a limited time. The CPU has to take the process in the manner of first in first out only, but for each process we are assigning some limited time, so of CPU time, that you call it as a limited time, you call it as a quantum time. You call it as a quantum time or time slice of CPU, or you can call it as a fixed means that is a fixed time. So a time that is assigned to each process, you call it as a quantum. So just remember that name. The quantum is nothing but a time, a fixed time is allotted to each process to execute the CPU. That process has to stay in the CPU, that you call it as a quantum. So if a process does not complete before its CPU time, let us take that the process does not complete before its CPU time expires, the CPU is preempted and again to next process waiting in the queue. Means it takes the next queue that is waiting in the next process that is waiting in the queue. Let me write that point, then you'll understand. If a process, let us take if the process does not complete before its CPU time expires, means that quantum time is expires, even though the quantum time is expired, the process if does not execute, if the process does not complete its work, the CPU is preempted, means it is taking the next priority, preempted. It takes, the CPU takes the next priority process, that you call it as a preempted. CPU is preempted and given chance to next process which is waiting in the queue. So that technique you call it as a round robin. So the preempted process is then placed at the back of the ready list. So this is how it will be executing. Let us see the example, then you will understand this round robin technique. Round robin with, let us take the time quantum is a fixed time for each process. I am taking as 20. So starting only you have to assign some time quantum to each process, that is a 20. Let us take the process P1, P2, P3, P4 and the burst time for this process. Burst times are, let us take 53, 17, 68, 24. So these are the burst time for this process. Now how it is going to be executed in the CPU, how, in which manner? So first P1, what is the burst time, what is the time that is allotted to the P1? Only 20, from 0 to 20. Still here some time is remaining, means this process P1 doesn't execute because the time is 53 but it given only 20. So 53 minus 20, still it is having 33 burst time limit. Still 33 time slot is there, means the P1 has to be executed in the 33, again it has to be come in the queue. So it takes only P1 take only 20. Next P2, so P2 they are given only 17. Okay, then the P2 will be executed within this quantum time 20. So 20 plus 17 you will get 37. Next P3. P3 burst time is 68, but we are given only the time is 20. So just add 20 here. 37 plus 20 you will get 57. So but still here you are having the time. So that is 68 minus 20. You'll still the burst time limited time is 48 remaining. Means again the P3 will come. Next P4. P4 they are given 24, but the time limit is only 20. So add 57 plus 20. You will get 77. So still 4 minutes will be there for this. So after completion of P4, again the control pass to, it is in round robin fashion, P1. Now P1 time here, still the burst time is 33, but our quantum time they are given 20. So 77 plus 20, you will get 97. Still here the time is remaining, that is 33 minus 20. Means there is a time of 13. Means the process P1 has still the chance is there to execute in the process. And P2 is already over. Next P3. So P3 here 48 is there. 48 minus 20, still 28 means is there. So just 97 plus 20, 117. So next P3 after P4. So P4 they are given only 4. So that 4 burst time can be executed in 20 minutes. So this will be over here. 117 plus 4 you will get only 121. Okay, so this is also over. Next again come to P1. So P1 the time slot is 13. The burst time is 13, but we are given the time quantum 20. So within that 20 the 13 will be executed. So P1 will be over. Next is P3. Next is P3. So here 28 is there, but our time they are given 121 plus 13. If you add 121 plus 13, you will get 134. So only 20 you have to be add. So just 28 minus 20, still 8 is there. Means again the P3 has to be executed in round robin fashion. So 134 plus 20, 154. Again P3 is executed, but this time only 8. 8 means 162. So this is how the process is executing in the round robin fashion. Thank you.